Welcome to Ionic bonding. To be honest with you, this chapter on ionic bonding might be the most important of all first semester. If there's one skill that you must master to be successful second semester, it's this concept of ionic bonding. So in general, the goal of bonding is to obtain a full outer shell of electrons. Most atoms do not come with a full outer shell, and having a full outer shell, having all your orbitals full, is very stable. The only atoms that naturally have a full outer shell are the noble gases, and that's why they're non-reactive. They don't need to make bonds. They already have a full outer shell of electrons. All other atoms will need to make bonds in order to occupy their entire outer shell of electrons. That's stable. We should put that in here. A full outer shell of electrons is stable. Now, most of the time, that means that we want an outer shell of 8 electrons, 8 valence electrons. It's called the octet rule. And it kind of says that atoms will gain or lose electrons to obtain 8 valence electrons. Magic number 8. So some atoms might need to lose a few, some might need to gain a few, but our goal is to get 8 electrons in the outer shell. And that would be 2 in the S, 6 in the P, for a total of 8. Now there are a few exceptions, and for the most part it's small atoms. Small atoms that might only want to fill the first energy level. The first energy level can only hold 2 electrons, so these atoms really don't need 8. A good example, hydrogen, helium. So helium only has 2 valence electrons, but it's actually stable because he's only filling the first energy level and it can only hold 2. Hydrogen has 1 valence, he'd like 2 to fill the first energy level. So hydrogen will try to gain 1 more. Other little atoms like maybe lithium or beryllium might fall into this category as well, where if they're going to lose a few electrons, they might just fill the first energy level, which would be stable with only 2. So these guys are stable with only 2 valence electrons. Excellent. Alright, so a couple little vocab terms that we should mention then. Atoms versus ions. Atoms are neutral particles. So for example, let's say I have a fluorine atom. A fluorine atom. A fluorine atom is neutral. The fluorine atom has 9 positive protons and 9 negative electrons. Neutral, no charge. Everything that we've talked about up until this point has been a neutral atom. However, neutral does not always mean stable. And here's kind of a big misconception. Let's look at the electrons in fluorine. Maybe we'll draw a little orbital diagram. So here are the electrons in fluorine. We'd have the 1s, the 2s, and these would be the 2p orbitals. Alright, so fluorine, number 9. I would have 1s2, 2s2, and I'm going to go across the 2p, 1, 2, 3, 4, 5. So technically I should fill them one electron at a time, but I'd have to go back and pair two of them. 2, 4, 6, 7, 8, 9. 9 total electrons. Here's the fluorine atom. It's neutral, but it is not stable. Stable is having a full outer shell of electrons. The outer shell is not full. The outermost shell is the second, or the outermost energy level. So we're looking at the 2s and the 2p. The 2s is full, but the 2p is not. We'd like to have 6 electrons in the 2p. We only have 5. This is not stable. Neutral does not always mean stable. The only atoms that are neutral when they're, or I should say stable when they're neutral, are the noble gases. They already come with full outer shells. They don't need to gain or lose electrons. All other atoms do. And when they do gain or lose electrons, they form ions. Ions are charged. They become charged from gaining or losing electrons. We're either going to gain or lose electrons. And the goal would be to fill that outer energy level. So in the case of fluorine, he'd really like to gain one more electron. Fluorine's got this open spot right here. If fluorine could gain one more electron, think about the balance between the protons and the electrons. We would call this then a fluorine ion. The fluorine ion. We still have 9 protons because we're not changing the nucleus, but if I could gain one more electron, I'll put like a little ghost electron in there. If I gain an electron, now we have 10. This is not neutral. This would add up to an overall charge of -1. The atom has no charge. Neutral. The fluorine ion is a charged particle that results from either gaining or losing electrons. That's important. Electrons. There's a question somewhere that'll say a positive charge is formed when you gain a proton. We are not gaining or losing protons. That would be a nuclear reaction, and we don't want to do that. We're just trying to fill the outer shell of electrons. So we're going to obtain a charge by gaining or losing electrons. Now this particle is stable. This is stable. And again, that's kind of a big misconception. People will see that this fluorine ion is -1, and they somehow think that the charge means that it's somehow not stable. No, the charge is a good thing. The charged particle means that we either gained or lost electrons to obtain a full outer shell, which is stable.